A coordinate covalent bond in simple terms is when one atom contributes both of its electrons to make a covalent bond with another atom. And the example we considered in class is a hydrogen ion reacting with an ammonia molecule. So if you draw the Lewis structure for ammonia, it will look like this. I'm not going to go over how to do that in this video. There's plenty of practice on our problem set on how to draw Lewis structures. But if you notice, and ammonia happens to be a very common donor of these electrons to make a coordinate covalent bond. Notice that it has a lone pair. Hydrogen has, this ion has no electrons. So what ammonia can do is use both of its electrons to form a bond with that hydrogen ion, which by the way is also known as a proton, because once hydrogen loses its only electron, it is left with just a proton. So here's what it looks like after they undergo the reaction. And still going to maintain that one positive charge because charges have to be conserved. And so right here, sometimes you'll see an arrow indicating that that bond was formed from two electrons originating from the nitrogen. So this is your ammonium. Too many colors. This is your ammonium cation, and this is your ammonia molecule, and this is just your proton, you can say, or your hydrogen ion. All right, the other example we looked at in class was carbon monoxide. Excuse me if I'm repeating myself, but I just got interrupted. So the other example we looked at in class is carbon monoxide, and I'll actually go through the steps on this one. Carbon contributes 4 valence electrons and oxygen contributes 6. So we got 10 valence electrons to build this Lewis structure, and there's no central atom, so we can put carbon on one side and the oxygen on the other, put a bonding pair there. That's going to use up 2 over 10 electrons. And then since oxygen is more electronegative, we can start with that terminal side and give it the octet. All right, so we've used 6 more electrons, we're down to 2, and then we can put the remaining 2 on the carbon. Notice the carbon does not have the octet, so when that is the case, you can take a lone pair and move it over and make a multiple bond there, a double or triple bond. You'll have to do that twice. And what you end up getting is a structure that looks like this. And by the way, we're out of electrons. And so one of these bonds is a coordinate covalent bond because oxygen came in with 6, carbon came in with 4 valence electrons. So this one of these 3 bonds, arbitrarily you can pick, was made using 2 electrons from one atom, in this case the oxygen atom. So we call that a coordinate covalent bond. Now it turns out coordinate covalent bonds become more common as we get into metal ligand complex ions, and we haven't gotten there yet, but just to give you a little preview, when you have we'll learn about hybrid orbitals in a couple days, but say you have a metal and this metal has an empty orbital. Let's just call it an orbital for now. And then you'll have what's called a ligand, like ammonia, the molecule, and that will have ligands are things that attach to other things. In this case, through creating coordinate covalent bonds. So this here is analogous to the nitrogen in our ammonia molecule. So I'll just draw that side by side so you can see. So that pair of lone pair is what I'm drawing right there. So you can imagine this is going to create a bond, or this can create a bond by using 2 electrons from one atom, in this case a nitrogen, to bond with that metal ion. And a real example, let me give you a real example, would be in a case like cobalt is a transition metal that commonly makes a 3 positive cation. So it'll have, turns out it has like 6 of these empty orbitals. They're hybrid orbitals, and trying to do this 3-dimensionally. This guy's like sticking out back there, and this guy's sticking out back there, this guy's coming out here. But anyway, there's like 6 of these empty orbitals for the cobalt ion, and so you can have 6 of these ligands. I'll draw 1 or 2 of them, and ammonia is a common one. And I'll draw 1 more here. So that here can contribute to making a bond, and that can contribute to making a bond, and you'll end up with 6 of these. And so these are complex ions when we get to it. But the point here is, again, showing you that when one atom contributes both of the electron to form a bond, we call that a coordinate covalent bond. Actually, a more formal definition would be the interaction between a Lewis base, which is the ligand, and a Lewis acid, which in our case, or our example, is the metal ion. But we'll learn more about Lewis acids and bases when we get to our unit on acids and bases.